Welcome to the DIY Honda Garage channel. The DTC P16E2 indicates a PGM-FI-ACG LIN communication error in the Honda CR-V 2023. This error suggests that the powertrain control module, PCM, is unable to correctly receive signals from the alternator through the local interconnect network, LIN, which leads to the storage of this diagnostic trouble code, responsible for generating electrical power and charging the battery. Additionally, the LIN communication system is integral in relaying information between various electronic components, including the battery sensor and the PCM. If the PCM fails to receive input signals correctly due to a communication error, it can severely hinder the vehicle's efficiency, placing additional strains on the electrical system and potentially leading to further malfunctions down the line. Therefore, obtaining accurate diagnostics is crucial for proper vehicle operation and longevity. The P16E2 error specifically points to a communication issue within the LIN, where the PCM fails to receive signals from the alternator, prompting a diagnostic trouble code to be generated. The PCM, or Powertrain Control Module, is the intelligent control unit of the vehicle's powertrain system, and it operates various components for optimal performance. The alternator, crucial for generating electrical power for the battery, plays a significant role in maintaining the electrical supply when the vehicle is running. The 12-volt battery sensor continually monitors battery voltage, ensuring that power levels stay within optimal ranges for functionality. The DC-DC converter is involved in regulating voltage levels to ensure smooth operation of electrical systems. All these components are interconnected through the LIN, and if any issues arise in this network, it can lead to significant performance drawbacks and current loss, necessitating thorough diagnostics and troubleshooting. A loose terminal connection at the alternator's +B terminal is one of the primary suspects when facing DTC P16E2. This can prevent proper communication within the LIN, resulting in the PCM being unable to read necessary signals. Furthermore, a faulty powertrain control module, PCM, might not relay information correctly, which can also trigger this DTC. Other potential issues involve a malfunctioning alternator, which fails to provide appropriate voltage and power, as well as defective wiring that could disrupt communication between components. A failed battery sensor may prevent accurate voltage reading, complicating matters further. Each of these highlighted causes needs to be inspected methodically to ensure that the communication error can be accurately diagnosed and resolved. When DTC P16E2 is present, several symptoms may manifest, affecting various vehicle operations. One common symptom includes the illumination of the battery warning light on the dashboard, signaling a potential issue within the vehicle's electrical system. In some cases, drivers might also experience poor engine performance due to inadequate power supply, resulting from inefficient communication between the alternator and the PCM. Additionally, electrical system irregularities can occur, exemplified by sporadic failures of electronic components that rely on stable power levels. Lastly, difficulties starting the vehicle might arise, as insufficient voltage delivery from the alternator could impede the cranking process. Addressing these symptoms promptly is critical to preventing potential long-term damage to the electrical and powertrain systems. For the first troubleshooting step, begin by physically inspecting the alternator's +B terminal. A crucial initial action is to confirm that the terminal is not loose, as even minor disconnections can trigger DTC P16E2. Sometimes, a simple visual inspection may not reveal the extent of the issue, so gently tugging on the terminal can help verify its tightness. If the terminal appears compromised, addressing this engagement with a thorough reconnect is advisable. Additionally, It's beneficial to inspect other nearby connections to ensure that no other issues exist in the vicinity. After securing the terminal and verifying the connections, clear the DTC and start the vehicle again to see if the issue has resolved. In the second troubleshooting step, turn the ignition of the vehicle to the on mode without starting the engine and allow it to remain in this state for approximately 10 seconds. This wait allows the PCM time to rehearse and assess the LIN communication setup and refresh its internal states. Checking the DTC status at this point provides insight into whether the initial communication error persists after the adjustments made during the first troubleshooting step. If DTC P16E2 reappears, further inspection of the additional circuits and components listed in the inspection outline may be necessary. Ensure that a proper diagnostic scanner is being used, as it can determine whether the reset was successful or if other errors present need to be addressed. Moving on to the third troubleshooting step, focus on inspecting the LIN circuit, which is essential for proper communication between the alternator and the PCM. Utilize a multimeter to scrutinize the connections, ensuring there are no shorts or open wires in the LIN BAT sensor. LIN circuit. An open wire condition may signal a break in connection, while a short circuit can disrupt data transmission through the network. Testing should confirm the resistance. Ideally, it should display less than 1 ohm for a functioning wire and greater than 1 mega ohm for no grounding issues. Identifying any discrepancies or abnormalities will direct you to potential wiring faults that require repair, thereby facilitating effective communication in the system. For the fourth troubleshooting step, verifying the alternator's functionality is paramount. Although there is no direct method to test the inner workings of the alternator, ensuring that it produces the correct output is crucial for trouble-free operations. One approach includes inspecting voltage levels while the engine is running to confirm that the alternator generates sufficient electrical power and charges the battery effectively. If the readings show that the alternator is underperforming or not generating power, it may indicate that the unit itself is faulty. Additionally, it's important to check for any noticeable physical damage or wear that may have developed over time, as these can also cause communication errors with the PCM when seeking signals from the alternator. In the final troubleshooting step, one has to inspect the condition of the PCM, as it is the last line of defense in determining whether DTC P16E2 is triggered due to internal faults. If previous steps yield normal conditions, it's time to scrutinize the PCM itself for any errors or signs of malfunction. A diagnostic scanner can reveal if the PCM is generating any DTCs, indicating its own failure. It is important to address and rectify these issues swiftly, as a defective PCM can lead to a cascade of problems across the vehicle's systems. If all else fails, replacement or reprogramming of the PCM might be necessary to restore optimal communication with other components, ensuring all systems function as intended. The final verification for ensuring the resolution of DTC P16E2 involves several key steps. Once repairs have been made, clearing the diagnostic trouble code from the system using a diagnostic tool should be the first action taken. Following this, a test drive of the vehicle is essential to assess whether the original symptoms or the DTC reappears. During the drive, monitor the performance closely, paying special attention to electrical stability and engine operations. If no codes return and the vehicle runs smoothly, it indicates that the resolution was successful. Continuing to observe the vehicle for a short time after repairs can help ensure ongoing reliability and confirm that no underlying issues remain. To prevent encountering DTC P16 and similar issues in the future, regular preventive maintenance is vital. Performing regular checks of the alternator's terminals and ensuring tight connections can help mitigate the chances of experiencing communication failures via the LIN. It is also advisable to conduct periodic electrical system tests to evaluate the integrity of wiring and to check for intermittent faults that may carry over time unnoticed. Keeping connections clean and free from corrosion is equally important, as contaminants can lead to poor transmission of electrical signals. Adopting this holistic approach to maintenance ensures the longevity of components and supports overall vehicle functionality. In conclusion, while dealing with DTC P16E2, understanding each component's role, from the alternator to the PCM, is paramount for effective troubleshooting. Following a structured, step-by-step diagnostic approach helps in isolating the root cause of the issue efficiently. The emphasis on physical inspections and tests ensures that potential faults are identified quickly. Moreover, performing regular preventive maintenance can save time and resources in the long run, reducing the chances of similar communication issues reoccurring. By mastering these procedures, Honda CR-V owners and technicians alike can enhance vehicle reliability, maintaining optimal functionality across systems. Please like and subscribe to the channel. See you next time.